This example is going to be real quick. I just want to talk about what exactly is concavity. So let's review. We have functions, and we looked at the derivatives, and the interpretation of the derivative is whether or not you're increasing or whether or not you're decreasing. Right? So increasing or decreasing. And if you take the derivative of your derivative or the second derivative of your original function, then that now tells you about the curvature. So here we're curving downwards. Here we are curving upwards. So we're either going to be concave up or concave down. So let's see x squared, right? The easiest example of concave up behavior, because if we take x squared and we differentiate it, we get 2x. And then if we differentiate that again, so the second derivative of the x squared function will be just a 2. So that's always positive. So the x squared function is always concave up. If we go over here and look at minus x squared, the first derivative is minus 2x. The second derivative is minus 2. So our second derivative is always less than 0. So this curve is always concave down. So whenever you were in algebra and you talked about quadratic functions, and your teacher might have mentioned it's always going to be an upside or a parabola concave up or a parabola concave down, this is why, because when you differentiate a quadratic function, you get a constant. It's either always going to be positive or always going to be negative. But the main idea here is when you talk about concavity, whether or not you're curved upwards or downwards, that concerns the second derivative.